one person that belongs here. Pete has been at Other Lab for 20 years, 15 years. Since Makani, what?
Yeah, depending on definition. Technically, at least 13, 14.
Yeah.
Maybe an extra year or two.
And has made so many unusual things. He started off his life as a kite surfing designer, kite design. Yeah. So.
Early years kite design. Came to the US to work at the Underpower on airborne wind energy, and mechanical engineering, mostly energy focus, robotics and stuff. All of them is engineering.
6.
It's almost got aerospace.
Oh.
A bit of that. Yes.
This is quite a drive, right?
It is,
Where do you live?
I just wanted to join the
party. But you don't have your name tag on.
Well, everybody knows me there.
Oh, okay. It's so Mark, do you know who this is?
Say yes, I'll bribe you. I'm Pete.
It's Pete Lynn.
This is your place. No, this is Saul's place, and I think he is actually in the country.
I think he is. I think he's in Yuba City.
Oh, okay. So
yeah. And he'll be there. Is that going to blow away? Your paper. Do you want me to get a piece of tape?
I only need momentarily.
Okay, we are going to start the excitement in 1 minute.
Is there an introduction sometime? You have to start?
I will start. I will start. We'll be Ted introducing everything. There, we got an oak pedestal. Is that better, the angle?
Yeah, couldn't be better.
I tell you.
It's a prototyping stuff, right?
Yeah, it's a prototype, but it's canted. In fact, it looks like a podium from here. I want to turn on the microphone. How do I turn on the recording again?
I can do that.
Thank you so much, Steve. Okay, we're just going to be quiet for a minute.
Don't tell me you promise to prove it.
Welcome, everyone, to Bay Kai. This is our monthly program, which happened every Tuesday at 7:30 p.m. since 1989, except for 2 times. Once when 9/11 happened, and the other time was at the first month of the pandemic. And we have been a forum that presents talks from the top people in the human-computer interaction field from all over the world. We've had everyone you can think of, including Don Norman and Ben Schneiderman speaking this year, for example. And we are a local part of the Association for Computing Machinery's SIG-Chi. ACM has 75,000 people, and we are the biggest special interest group in the ACM, that is SIG-Chi is. And there is a yearly meeting that this year was in Hawaii, where there was gigantic floods, and it was kind of exciting and great talks. However, while I was there, I hosted a Bay Kai talk by Mark Davis, a famous old timer who predicted in 1995 that there'd be 50,000 people making videos. And anyway, his talk I thought was better than any of the talks at the main Kai event. So very proud of that. If any of you would like to, and I hope you do, join Bay Kai for $20 a year. It helps pay for the IT and whatever we have to do to put on our events. And so, oops, now what's happened? This is some of the people that bring the place to you. And what we really And Melissa Guire is now not just interim, she's been voted in as the actual treasurer. But we are excited about anybody that wants to help us with outreach, with figuring out many things that we'd like to do better. We edit the videos every time, and we have 10 or more times as many people watch them on YouTube than come here every month. We're very proud of that. It's an important part of what we do. So please come to the steering committee if you were interested in sharing and being part of the team and thinking about what we should become. Okay, now we have today a very exciting speaker, Mark Stefik, who I worked with so long ago, I won't tell you the year, but at that time he was making a room that was full of screens, and you could collaborate with anybody in this room in a way that allowed you to use these tools, ArgNoter and CogNoter, to help amplify people's collaboration. And we had an anthropologist in the back of the room watching these experiences. We wrote papers together, great big fancy Dorado computers, hundreds of thousands of dollars for these personal computers that now probably aren't as fancy as what was in your pocket, but they were incredible. And the software was written by the people that worked there with Mark. Mark worked on many things over his career at Xerox PARC, 45 years, was it?
Close to.
Yeah, close to, including he's probably has done more for understanding digital rights than anybody else in the world, has patents on it, and he's done a lot for creating the languages and the ways that AI languages work. He has recently did a very big project on explainable AI that was a big DARPA contract across many organizations. So great guy, and I'm very proud to have him here. And he wants to talk about creating AIs with human compatible values. And I want to know, Mark, whether you want us to hold our questions or dive in as we're doing this to ask questions of you. And I just realized I have not given you a microphone. Likes if we have to. Still no microphone. Okay, I will just go and select that one. Do it again. Go over here and select this.
Yes. Oh, I should say something. I have to have something to say, though.
I can hear it.
You're good. Oh, good.
All right. So it's working.
So are we on? We're starting?
It's working, right? Okay, we're on. So Mark, please tell us about creating AIs with human compatible values.
Thank you for having me. I've been looking forward to this talk. I've been on an adventure for the last year or so, having completed that DARPA project that Ted mentioned, at the end of which I believe we delivered everything to DARPA they needed to know. I've got papers on it. That's not the subject of tonight. But at the end of that, I just said I didn't know what I was talking about. That I really needed to rethink AI. And say this as a person who's written AI textbooks, who's been in the field for a very long time, who has also been between AI and Chi. For a substantial part of my career, I wasn't sure which field I was in. And as will become clear in this, I'm probably in both. But in a sense, I'm really finding out that questions matter. So this talk today is really going to be about interesting questions we can ask, especially if you have a field which is doing things, but it doesn't have the basis for asking the questions that it really needs to ask, which is a theme that I'll be going through today a little bit with you. So this is about AIs with deep, like what is a deep human compatible value? What is a human compatible value? That's something that Stuart Russell promoted very much in his textbook. Ben Schneiderman also has been talking about that. But I think part of what's been happening in a big way for the last 10 years or so has been the rise of machine learning. That was important for the project I was working on. It's important for what seems almost like a land rush right now. As the chips are being built, the foundation models are being built, cloud computing is happening. People are starting to build applications, and lots of questions are being raised about what the AIs are doing. So a fundamental thing, which I've heard lots of times in this sort of good news, bad news, it's great, I'm terrified conversations that fill the media is, do AIs have values? In fact, there's 4 questions here I wanted to raise with you, which are kind of worries that people ask about. Can this AI cause harm? Is decisions safe or are they biased? What should AIs prioritize? Is this AI trustworthy? That's where the explainable AI stuff sort of came in. You want to know, why is it reasoning this way or that? Under what conditions is having a human in the loop improve things or make them worse? Okay, are future AIs powerful enough? This one's kind of amazing. It traces back to mythology and so many stories about the machine that got built, the sorcerer's apprentice. Will AIs take over? Will we become as humans obsolete? So what is the basis for asking questions like that? The worry that I hear from people is, well, what values do AIs have? And so this is where my beginning on questions will come to you. Here are 5 questions, which I believe we could ask in AI, but which AI doesn't actually address. What are human compatible values? And what is their nature? Like, what is a value anyway? Here's one of my favorite questions. What are their origins? Like, where do values come from? And what is the utility of a value? If you have a value, what does that improve for you or for the species? Now, we're talking about building human compatible values. If that really made sense, why is it that different groups of people have different values? So human compatible to who? Is that question? I don't even hear that question in the common debate. Another question: how do we acquire values? Are they innate? Are we born with them? Where do they come from? Are humans the only creatures that have values? Do whales have values? So I will touch on some of these things as we go forward. Or even if we build AIs that are supposed to have values, will they maintain those values? How might that work? So those questions, as it turns out, and as we'll touch on as we go through here, actually come from different disciplines because AI is not asking them. So I wish to give you a little tour of some of the places where those questions get asked and where possible answers lie. But before starting the tour, I want to read you something about the nature of questions. I ran into this just a couple of weeks ago and I loved it, and so I want to share it with you. It's a very short quote by John Donahue. A question is like a lantern. It illuminates new landscapes in new areas as it moves. Therefore, the question always assumes that there are many different dimensions to a thought that you are either blind to or not available to you. So a question is really one of the forms in which wonder expresses itself. So we ask because we're wondering something, we ask a question about it. So I love that. I love the sense of wonder, of exploration. And so I will ask these questions about AIs and the possibility of building them, but trying to ground us in questions which can actually lead us towards answers, which can tell us things which aren't even in the public debate right now. That's why I hope that you enjoy these. You asked whether to take questions as we go. If we have a short question, I'll try to answer it. Otherwise, I would like to leave maybe 30 minutes or something at the end where we can just have a general discussion about whatever's on your mind that comes up as a consequence of the things we've talked about. So these questions about AIs and are they biased and so on, these have been the subject of science fiction, mythology, cautionary technology essays for a long time. And similar concerns have come from all those different places. And the view, like if you listen to Elon Musk's recent talks about Optimus, he envisions robots in the home, robots in the hospital, robots in different places. It seems, though, if we want to have robots in these critical roles, our concern about the values they have are different from the concerns you might have about a little iRobot that's buzzing around the room and getting the dust up. It matters what the robot or the AI is doing, whether we really care what its values are. So I'd like to start with a really very basic question. What's a value? Now, in asking this question, I'm not trying to, I will touch on a number of different values. And you could, we'll say, well, who writes about values? Well, it turns out there's different theories of values that draw on. These are like sort of separate domains. There's philosophical theories of values. There's economic theories of values. There's ethical principles of values. Okay, and those are all like different domains that say, these are the values. When I first asked these questions, I thought, where do values come from? And I thought of things like the commandments and the Christian religion. Are those values? Or I thought of Isaac Asimov's laws for robotics. Do those express values? So my question, what are values? So I want to look to see who's got theories of values. So a first one I want to mention to you is Brene Brown. Some of you may know of her. She's a great speaker on leadership, and she has a list of 100 values. So I'll be giving examples of values just to give you a sense of the range of what these things could be. So she says, well, the values include accountability for leaders, adaptability, altruism, authenticity, confidence, courage, integrity, loyalty, and the next 90 of them. So there's a whole bunch of things that she calls values, 100 and some. Well, here's another source of values. There's a book written by a couple of parents who had a lot of children. It made a lot of, it's Linda and Richard Eyer's popular book on teaching values to your children. What are their values like? Well, they actually have two kinds of values of being and values of giving. So they will include honesty, truthfulness, trustworthiness. Imagine asking these things of an AI. Is it trustworthy? Does it have integrity? Courage? Is it peaceable? Well, courage, you might think of, will it sacrifice itself for a human, or what you could, will it go into a dangerous situation? Should it protect itself? So I'm not trying to take a stand on whether it should have that value or whether it's a good value. I just want to know what a value is. And so these were examples. Some of them, it's not clear how they apply to robots. Chastity and fidelity, self-discipline, maybe, self-reliance. Okay, well then, here's an extreme theory of value. And this one, there's a couple of people who espouse this one. They say integrity is enough to explain all the rest. Now this is Werner Erhard. Some of you may have heard of him in EST, and his co-authors, Michael Jensen and Steve Zafroni. Basically, they say, look, there are these domains of values, but no set of values works if your total set of values doesn't make sense as a whole. Another sort of writer, Martha Beck, has The Way of Integrity. She espouses essentially the same theory with a lot less philosophy. So now I want to look at the science that could underlie this question about what values are. And the person I'm going to go to first is Robert Axelrod. You might know of him from the Prisoner Dilemma and all the research experiments he did on that. Here's Robert's question. Under what conditions will cooperation, so I was looking at cooperation as something that we might think is valuable. Under what conditions will cooperation emerge in a world of egoists without central authority? Like if somebody can impose it or write down these are the rules, maybe you could get cooperation to happen. They don't want to work together. They must work together. The question has intrigued people for a long time, and for good reason. We know that people are not angels, that they need to look after themselves and their own first. Yet we also know that society, cooperation does occur, and our civilization is based on it. So without cooperation, we wouldn't even have a civilization. But in situations where each individual has an incentive to be selfish, how could cooperation ever develop? So when I read his book, The Evolution of Cooperation, that question rang in my head. How did it evolve? And then I remembered, because I had a long career and dipped into a lot of different kinds of fields, I remembered sociobiology. How many people here know of sociobiology or as a field? A few of you do. So this is a branch of biology that includes the study of animal behavior in social species. And Edwin O. Wilson is predominantly known in that thing. And Wilson had a very direct and simple answer to that question about anything that emerges from evolution. He says the brain, or any cognitive system, or any other part of your body, emerges because it promotes the survival and multiplication of the genes that direct its assembly. This is like Richard Dawkins' The Selfish Gene book from 1976. So there was a lot of confusion about things like altruism, which I'll come to in a little bit. So, but look, there's an engine. That engine is evolution. It causes mutations. It tries out a version of the body. If it succeeds in reproducing, you get more of them, and that's called success. So that's where. So that would mean that brains or anything else that holds something which governs behavior is going to exist because it favors on the survival and propagation. But then so then he studies, this is Edwin O. Wilson, found himself studying insect behavior, insect altruism, human behavior, wolf behavior, whale behavior. And one of the things he's puzzled about is, well, he said the differences between the vertebrates and insects and how they do cognition is immense. And yet they're similar in very many important ways. So he's looking at parallel evolution, but the evolution has to be something whereby these things, which we'll call values or competences, we'll get into the relationship between those two things, are there because evolution puts them there. Okay, so I still haven't defined a value. I've simply said, these are examples of them. And I said, well, gosh, there's 100 of them from Brene Brown. There's 12 of them from this person. And Werner Erhard says there's only one. It's called integrity. Well, operationally, what do we want to say is a value? I see Ted smiling. Maybe this is getting to be humorous, but it's just. But notice when people say, "My God, what values does the AI have?" We don't even ask the question what a value is. And I'm trying to take you on a tour of how we might answer that question. I'm trying to give you an operational definition of a value. The agent's values are its interpretations of the conditions that govern its actions. In other words, if you think of an agent as doing things, it decides when to do it, what to do, and that sort of thing. The conditions under which it does it will govern its behavior. We are looking at behavior when we're trying to induce what values the agent has. Okay, now we sort of have a way of how we can infer the values of something by seeing whether that behavior is consistent with owning a particular value. So going on to the next sort of piece of this thing, well, let's take altruism then. Altruism is sometimes said to be a value. It's one of the ones that was a big puzzle for sociobiology. And altruism is where a member of a species takes on a behavior which serves others but doesn't necessarily serve itself. Also, so there's a big controversy about this back before for the 1970s. Like, how can we explain it? And so let's look at the case of ants, for example. So in ants, worker ants, most ants are actually sterile females. Reproduction in the ant colony is done by the queen with an occasional male contributing a little bit to it. And the worker ants sacrifice themselves. From a selfish gene point of view, which is like, how does that gene propagate? How does that possibly work? Well, these ants don't reproduce anyway. The genes that they carry are exactly the same genes that are carried by the queen. So if they ensure the survival of the colony, their genes get propagated more. So altruism begins to make sense from the selfish gene point of view, even for animals like ants. And then you can ask if an uncle sacrifices himself for a nephew or niece, swimming accident, and he has a tragic accident, but the kids are safe. Well, they have a lot of genes in common. So you begin to see that. So but which altruism isn't the only gene. It's not the only gene that we care about for machines. What kind of values are going to matter, say, for machines? And what the sociobiologists were looking at, they see a mixture of a certain collection of values. They named three: personal survival, reproduction, and altruism, or Wilson's choice. But I want to take this a little bit further to look at something that's common about the animals that are surviving better than other ones. So this is like the second move in my story to you about values. I want to talk about certain classes of values which we all have and which seem to be at the core of all these concerns that people have about what AIs will do. And these are going to turn out to be values relating to cooperation and collaboration. Why should we look at those things? Well, let me tell you a little bit about some critters that you're probably familiar with. Many people think of orcas or excuse me, killer whales as being the apex predator in the seas. Now you may not know that there is also orca, which is the killer whale. And if a killer whale, a group of killer whales comes into a region where there are killer sharks, the sharks flee. They can't get out of there fast enough because the killer whales will eat the sharks. What is the advantage that the killer whales have? They cooperate more. The grandmas teach their kids things to do. They teach them hunting techniques. They hunt as packs. So in this case, we can see that the social species with the highest level of cooperation is the one that survives. Well, in turn, sperm whales hunt orcas. And in turn, they have a higher level of cooperation, language, coordination, and so on than the orcas do. So what I'm reaching for here is the insight that cooperation, collaboration is something that humans have really dominant over all the species that are around, in that we're able to share knowledge, we're able in principle to cooperate with each other. So let's pay attention. And so if you think, is the AI trustworthy? Well, that's actually kind of an issue about cooperation. Is it doing something harmful for us? That's hardly cooperation. So I'm suggesting let's focus on values from the perspective of AIs, which have to do with cooperation. Now we've seen that, and cooperation, as we've seen in the case of the whales and many other ones, actually improves the survivability of the species. So that would probably be true for us as well. So now going more into values here, I want to talk to you about the representation of values. So how do we come to learn, like if we take a value like trustworthiness or lying or something like that, how do we interpret what it means? So I'm going to give, how do we learn the values? How do we acquire them? And then how do we reason with the values? Because a value tends to be a sort of an abstract thing. How are we going to get down to actually applying that value in the choices that we make in living? And then the choices we make in living will be illuminated by the behaviors we have. And so other people could watch our behavior to say whether we have that value. But how complicated is that? Is a value a simple thing? So let me give you an example of a very commonly agreed upon value. In the Christian commandment, thou shalt not kill, or don't kill. Okay, so imagine that there might be different perspectives on killing. Do you make an exception for killing animals? How about killing during war? Let's look at the reproductive rights movements and what's going on relative to the notion of killing there, or even in vitro fertilization, where there's many tiny embryos being created but not being used, or maybe they're being tossed, or whatever's going on there. Is that killing? And so my point here, I'm not trying to take a stand on this thing. I imagine everybody in the room's got an opinion about where the line of killing is, or where life begins and things like that. Might be an interesting discussion later, but I just wanted to point out that just saying do not kill doesn't tell you very much, because then you've got these edge cases and exceptions which have to be interpreted. So we try to, when we give rules for things like that, we typically use symbolic language. So here's an example of a little piece of symbolic language. It's just the modus ponens, but well, here's the one. All horses are mortal. Socrates is a horse. Therefore, Socrates is mortal. Great. Okay, we got that. I know Socrates is usually done as a human, but I'm doing it as a horse. Okay, well, let me give you an example from Fei Fei Li's book, and she's used it in a couple other places too. She has an AI system. It's looking at a picture. The picture is of a military statue of a bronze man and a bronze horse riding, and the program is supposed to write a caption of this thing, and it says, a man on a horse. And so when they saw this was a subject of humor within the AI lab, because it left out that it was a statue. Well, what did it know? What didn't it know? Well, it didn't know that a horse couldn't stand still on a platform in the middle. In fact, it didn't know anything about the meaning of any of those words. It didn't know what a horse was. It didn't know what running meant. Like if a horse runs, and that's different from like running for office or a refrigerator running or whatever. So there's all this stuff about meaning, which is not captured in just the symbolic rule by itself. So if we think we're going to be able to express values by a set of symbolic rules, and that's all we're going to have, this problem of interpretation is going to be rampant for all the cases where we try to figure out what it means. So to take horses again, are donkeys horses? About mules? I mean, and depending on how much you know about equestrian genetics and stuff like that, you may have opinions about about those things, and some people do. But so man on a horse became funny. My point of this thing is that the representation required for interpretation tends to be complicated. Now, this is the place in the talk where I want to bring yet another idea in. In this case, it's not coming from sociobiology. It's not coming from the study of cooperation and stuff like that. It's coming from, good God, AI. Okay, so what is the idea I want to bring in from AI? So deep learning hit, and deep learning ate symbolic computing. Now you could say, well, maybe that's not exactly true completely, but it sure did a lot better on a lot of problems than the symbolic stuff, especially in open world problems where all these edge cases and special judgments have to get made. So I'm going to just use the term here. I'll say a deep value is a value which is represented the way the operations in deep learning are represented, with lots and lots of different kinds of examples used to fill in all the cases and so on that you're going to make judgments from. So deep value refers to a rich, nuanced, contextual, high-dimensional representation of a value. So now if I say this AI's got honesty, you're going to say, okay, it's got honesty. You say, now we're going to try to figure, well, is it honest when you can't see what it's doing? So I guess the claim here is that using deep representations without deep learning will not be adequate for guardrails. So the call right now, and this is the call which isn't just like casual. Governments around the world and stakeholders of other kinds are all saying, AI, we got to regulate it. We want to address these fears and make sure that it has appropriate values and the appropriate behaviors. And partly what I'm saying, and I will be making the case here, is that currently the technology does not exist for making robust and general judgment about values or guardrails. Okay, I'm not saying we can't get to that, but it's going to take doing some things that we aren't doing right now. We aren't asking the right questions. We aren't bringing in the perspectives from these other fields, these things that provide our sense of wonder, but also our sense of deeper understanding. We're not bringing them to the party. So the next thing I want to bring to you is if we look at things like large language models, those are largely symbolic, that they get labeled, and well, there's different things you can say about them. But if you want to have something which behaves well in the world, the experiences it has have to be representative of the things you're trying to learn. So in other words, you need experiential training. The databases can't just be labels of horses and of course, there's unlabeled versions of large language models and so on as well. But the questions you need to ask aren't going to be about language performance. They're going to be about performance in a task and deep understanding of the things that matter for people. So I want to give you an example. Let's see if I can skip over this thing. Okay. The next piece I move to is external cognition. So this is where my HCI background begins to come in. So how many people who know about external cognition? Like a few guys. So it means like we're using a whiteboard to explain things. We draw pictures. So we come to agreement about what's on the board. I want to give you 3 examples of teaching moments, which I found enormously fun, but giving a little more insight into these things. Teaching moment number 1. A friend of ours told of a day when she got so upset with 2 small preschoolers fighting over a doll that she grabbed the doll and threw it out the window. She then lectured the children on sharing and not fighting. And she was sure when she was done that she had taught them something. And she had. Later in the day, she saw the 2 kids throwing bread out the window. Okay. So we teach things that, what did they learn from that experience? There was an experience there. That's my teaching moment number 1. My teaching moment number 2 is of the more positive side. This is about a dad who really likes to keep the house clean. He doesn't want garbage left. The son is supposed to take the garbage out. Don't leave dishes in the sink, all that kind of stuff. So one day when he's waiting, he's standing in the kitchen. Son's coming home from school, got his backpack, walks in the room, drops the backpack, and the father has taken the garbage can in the kitchen and pulled it into the middle of the aisle. You can't walk through the kitchen without seeing or avoiding or walking around the garbage can. Son comes in, dances around the garbage can, throws the backpack and thing, goes to his room. Dad says, okay. So a little bit later, Dad goes to the room and says, he says, could you just come with me, Dad? I just wanted to see what's on your mind. And son says, okay. And so they walk into the kitchen and Dad says, what do you see? and he says, "Oh, the garbage can. I didn't see it." I thought this was a remarkable story of good fatherly training. But for a couple of reasons, it meant to pay attention. So paying attention and being able to see things is part of this business of getting a deep meaning. And noticing what's there is truly important. So, and he was in this case, trying to give his son a skill. And according to this was only 3 weeks after the event when I got the story from him. But at least for those 3 weeks, the son was now getting it every time. I thought, well, how marvelous is that? I just have my third story. Okay, this is about triple twos. I don't know. I'm just glancing around the room. I'm guessing a few people here have kids and know what the terrible twos are. So this is an age when little kids are sort of growing up and they're getting language and they're doing. Here's the story. This is from Alison Gopnik, who's a developmental psychologist at Berkeley. When 1-year-olds seem irresistibly seduced by the charms of forbidden objects, like imagine a lamp, and an electrical cord. The 2-year-olds are deliberately perverse. A 2-year-old doesn't even look at the lamp cord. 2-year-old looks at you, moves the lamp cord, and sees what you're doing in a very perverse way. What's going on here? He says, what you have to understand is that this 2-year-old is like the scientist in the crib, is the name of her book. You are the lab rat, and the kid is finding your boundaries. So now we're beginning to see this marvelous interaction between parents, kids, teaching, kids trying to learn. So I'm trying to give you a sense of the experiences we have when we were 2-year-olds or when we were the high school student, not seeing the garbage in the kitchen. Like that. So there's this whole bit of a relationship between parents and children. So what is the difference then of social species, which are using these cultural ways of imbuing values? So I want to tell you that there are 3 ways. This is probably a place where I could have used slides, but I told myself I was just going to try to pay attention to all of you and speak from the heart, and I'll just wave my hands a little bit. Okay, so there's 3 broad ways in which we learn things. Some stuff's innate, so we're born knowing it, and this is different across species. So like a deer, when it's being born, can run. Evolutionary pressure is such if they can't walk soon, they're more likely to get killed when the lion attacks or something like that. Okay, so that's innate. The bottom level is going to be innate. The next layer up there is self-learned or self-trained. So this is like the kid who's experimenting with the parents. It's like if I throw this in the air and don't catch it, or you are probably couldn't help it. You're making predictions. He's going to catch it. No, he's not going to catch it. It's definitely coming down. Right. So you were making predictions all the time, but you had to learn to do that. I'll tell you a story in a second about learning to do things and how we can probe those things in building AIs and other things. But that's self-learned. We all do experiments and we get good at knowing the world because we live in it and experiment with it. That's another one of the differences between using things like large language models and using things that are experiential. People and whales and animals do experiments in the world to figure out how the world works. We build models of the world by doing experiments. That's level 2. The third level of sources of knowledge is socially developed knowledge. That means we don't have to learn everything ourselves. And let the sirens go by. Okay, so socially developed knowledge is learned by other people, possibly over generations, maybe even generations before us, and we are taught it. So part of what Gopnik notices is that, well, you got the picture? Oh, okay, so, right. Ted has innate at the top. This isn't going to help. But in any case, innate enables experiential enables social. Okay, thank you. And so we can even read things or left to us, like the invention of writing, the invention of all those things. So if you think about why do we have, why is it important for animals that do experiments in the world? Well, evolution doesn't go fast enough. So so animals that could learn things happening in the world wouldn't have to wait for generations and generations of trying to build that in. Similarly, when we learn things from other people, we save all the time of doing that because we get it from others. So this comes back to notice that this business of teaching other people, learning from others is again a form of collaboration. So now I'm saying that these values and competences that have to do with cooperation seem to be quite fundamental for why we survive, why we're sort of where we are in the food chain and so on. Okay, so the next piece I wanted to bring to your attention is that, well, there's a question here, which is how do, I'm looking for something here. How can we tell whether somebody has a value? Oh, sorry, let me fumble for this for a second. What I'm looking for is a story. Well, I'll just tell you the story. There's an old television sitcom, Leave It to Beaver. Okay, and there's some of you have seen it, some of you have never heard of it. It's a family sitcom from the 1950s. Beaver Cleaver is the son of, he's got June Cleaver and somebody else. And there's a kid in the neighborhood, Eddie Haskell, who became a cultural archetype because, Mrs. Cleaver, what a nice dress you have. I'm sure that Theodore, so you can sort of get the sense he's playing one sense of things to the parents. And another thing was when he's with the kids his own age, he's really mean. He called them names, you're a pig, you're fat, or the sort of thing. And perhaps you've known that, but he became such an archetype. I think he was supposed to be in one or two temporary episodes, but the audiences loved it so much. He became a permanent feature of the show over many seasons. And which the point of that relative to the story is, if you want to observe whether someone has values, you have to see them in lots of circumstances, not just when he's playing up to the parents, but also in other cases. Same thing for why diverse experiences, diverse experiential learning is critical for learning values, learning the edge cases, learning when it's true, and for observing whether somebody else has a value. So what does this tell us then about the values robots might have, or how they could have them? Well, Isaac Asimov, probably many of you have read his stuff. He had these laws of robotics. Turns out he started out with 3 laws of robotics, which I'll give you first, and it later got expanded to 5. Let's look at them for a second. First law, a robot may not injure a human being or through an action allow it to come to harm. This is from his 1942 story Runabout. Okay, so that's like the first thing. Robots shall do no harm, like be good or something like that. I will take note before I even get to the other rules that the substance of Asimov's stories was that the rules weren't specific. This goes back to the business of trying to express complex, nuanced values. So most of his stories were cases like, should not hurt a person. Well, what if that person, well, like rule number 2, robots shall obey the orders given them by a human. What if the human is telling him to shoot people? Well, wait a second. So that's rule 2 would say, unless it violates rule 1. Well, rule 1, what if he should harm? What if there's a person who is a really evil person? It's like a school shooting. Should that be allowed? Or take a military operation. I'm not going to get into, well, at least not now, have a discussion about is having a military good, should you ever protect yourself? Should you be like Gandhi? But the question will come up, is that a form of killing, which is okay? It's like the do not kill sort of rule. So most of Asimov's stories were places where the robot had these so-called positonic brains. And if they got into a situation they couldn't resolve, the brain would melt. And so this would be the end of this is his fictional motif for that. So rule number 3, a robot should protect its own existence as long as such protection does not conflict with rule number 2 or rule number 1. Well, those rules served him for maybe the Foundation series, and there's another couple of series that he wrote for a long time. But then it turned out that late in life, by 1985, he decided to extend this notion of rule interpretation with rule 0, law 0. A robot cannot cause harm to mankind. Maybe he would have said humankind if he's writing it more recently. Or by inaction, allow humankind to come to harm. So you have to renumber and re-index these rules a little bit so that there will be a set of levels. But then Harry Harrison wrote a series of stories honoring Asimov, added another rule. A robot must be produced as long as such a production does not interfere with, rule 4, rule 3, rule 2, rule 1, and so on. So here was an attempt to give a set of priorities for things. And we can sort of see how the priorities would govern behavior in some cross sense, but we're still left with the question, how do we get the grounding of what the rules mean? And what do you do in the stories where there's ambiguity between which rule, whether is this an exception condition for the rule? So looking at, I guess the next phase of this thing is, I want to say, going now to the question, why do different groups of people have different rules? Well, so here's a couple of stories from Park. There's a, and this is part of my vision of where I think we would like to have AIs with values go. And it goes beyond this question, like, are they going to take over the world? So I'll teach you a little bit of something from Bob Taylor, who was a famous lab manager at Park. And my wife and I wrote a book called Breakthrough, which we interviewed a bunch of people. Taylor was one of the people that we interviewed. Here's a little blurb from what he had to say. When the laboratory was trying to do a project, so this is an innovation group, they're trying to collaborate with each other. There might be two teams, they've got a big disagreement about which way to go. You would say, okay, there's a disagreement here. There's a stumbling block that our project is facing, that there are sometimes various opinions about how we should hash them out, but there may be disagreement at the end, even after they've talked about it. So I invented something called a class 1 and a class 2 disagreement. A class 1 disagreement, class 2. A class 1 disagreement is the one that most people have. They disagree with each other, and neither can describe to the other person what their position is. And a class 2 disagreement, like if Ted and I had a disagreement, Ted's wrong, but I can convince Ted that I understand his argument, and vice versa. So this was a part of the lab culture. I mentioned that just as an example of a lab culture. It's invented by groups. Design groups do things like this. How do you set your priorities? How do you argue things through? And the idea, or take a group of surgeons. People have different kinds of jobs there, but they have to back each other up. They definitely have to coordinate. So they will invent a collaboration culture where they have like effective architecture for situation awareness, for helping each other when needed, for noticing something that's going wrong that the other person needs to be aware of. Architects have, when they're working with engineers, have to do similar kinds of trade-offs. My thesis here is that every culture invents a culture of collaboration. So if we say collaboration is an important value, part of the observation is collaboration depends on the people and on the task. You have to understand what that task is. And so, so first point is we have different groups of people, different needs for collaboration, different cultures for it. The second thing I'm going to hear is a quote from Danny Barbaro, who's a longtime collaborator with me. And this is getting back to the notion of wonder. He noticed that when he's working with someone else on a problem, they probably have different backgrounds. They know different things. And so we are looking at the intersect. It feels like I'm wandering through a space in which I see some patterns, and the other person, possibly from a different discipline, sees different patterns. Now, I am not a musician, says Danny, but I have this feeling that this is like doing music, where the music does not come out of the instruments that are playing alone. The music comes out of our interactions. So Danny refers to these interactions, and he says, for me, that human interaction is exciting. We would get into these discussions, we would play the game, we would switch side. We'd say, okay, trade sides. That's sort of like class 1, class 2 disagreement. But trade sides is not only can I explain Ted's point of view, but I now have to own Ted's point of view and come up with the best argument I can for why it's any good, and vice versa for Ted and me. Again, this is another example of a cultural pattern for collaboration. So I want to give you my thesis. I've actually now concluded with all the sort of little lessons, but I'm going to give them to you all at once. You can sort of see that there's a story here of what this has to do with values. Point 1, organisms with competences and values for communicating and coordinating have advantages over others. They can collaborate. So values about collaboration are really paramount and are at the root of most of the things that people who are worried about AIs have in mind. Shortcomings in these values are the core of the concerns about AIs. Deep values for trust are nuanced and complex. They require big data, experiential and diverse learning to master them. So just having symbolic rules isn't enough. You've got to really have experience. So the data required for robustly learning general values and competencies comes from diverse experiences. So you should be, if you're going to be an innovator or a designer, you've got to be in enough design cultures to know how to collaborate with people. Finally, if robots aren't going to be good at collaborating, they've got to learn the collaborative practices that people use. In other words, it should be the case, and I think this is consistent with the sorts of things that Elon Musk is saying about Optimus and so on. You should get at home, you should be able to teach it things, you should get to know you and your family. It's going to be constantly learning. It's not a question of having a discrete set of rules. The robot has to be learning all the time, has to learn about the people around it, has to learn what our values are. So it's not like we can finally write the guardrails by God, and now the robots are safe. It's harder than that. We have to have robots that learn to collaborate, that learn the values that we have, that we can train to do the things that we need. And we shouldn't think of the robot with perfect values any more than you can think of a person with perfect values. The game is different than the game we're playing. And that's what I wish to leave you with. And I thank you for your attention and open for questions now. Thank you.
Thank you so much. It's a great talk, very interesting. And I will start off by asking a question. You can hear me on this microphone? Yes. So it seems like values are a generalization of learning in these different ways, these experiential
Values
and
have to get
social.
learned.
What?
Values have to be learned, and they can be general.
Yeah, but if we call them values, does that mean that they are generalizable over new instances?
No, I guess I'm saying you've got to see enough instances to get it right. You don't know where the edge cases are coming from. So I see this as being like Tesla when they switched from having the manually constructed self-driving instructions to incorporating more machine learning. You can never catch all the edge cases. So I think learning is fundamental, and values get learned all the time.
So values have to be flexible.
Well, I think you can have, yeah, but I think you can have abstract versions of values, but whose extensions probably need to be tested. You can have more or less confidence that you've seen this case before.
I hate to ask, but I'm going to ask another question.
Maybe I'm missing the thrust of your question. I don't know.
It's okay.
Okay.
It's okay. I think your answer is interesting. So as you were talking about values, they all seem very philosophical. And then I thought about how some people are very, especially engineers, are pragmatic.
Mm-hmm.
Is pragmatism a value?
Sure. Why not?
Okay. I kind of think that's interesting. Please, somebody have a question?
Because you get stuff done, right?
Yes. Let's pass this around and say what your name is. Is your...
Sure. Hi, I'm TJ. I have less of a question and more of a, like, I'd love to hear you say more about experiential learning versus non-experiential learning.
Sure.
And how that might get captured in such period.
Okay. So this is actually the, on my website, I list four papers I've written in last year. I mentioned that I sort of went back to grad school over the last year. That resulted in 4 papers. One of them is it's about collaboration per se and what it takes to be able to collaborate. Another one is what AIs are not learning now and why. And the next one is about values. And then there's a long paper. It's 100 and some pages. It dives into the neuroscience, cognitive science, all the sciences and the state of the art right now relative to building these things. And it describes foundation model for robotics. So, and an experiential foundation model is one where the data that drives it comes from the robot or AI having experiences. Now, I should offer a caveat about that. Like, let's say, Ted, you're so conveniently located right here.
I'd like to be.
This is actually TED number 437, because they are all copies of TED number 10, which was the first really successful one. There's some branches in it, so they have to get together now and then to exchange values. You can see where I'm going for this. You don't have to send every robot from babyhood, all the way through. So, but the experience but the learning has to come from experiences. Absent the experience, you don't really know what to do. So I define the values as being what governs the decision of what decision to make, what action to take, and so on. It's the interpretation of that. And Ted was asking questions about, well, is it general? Well, I mean, if you look, I mean, I think that Hawkins' book, Thousand Brain Theory, those of you who, any of you who paid attention to that one, and the way the neocortex works and the columns in there and so on, it's a race. So all those columns are firing, and like the ones that broadly speaking, the ones that get fired the loudest, the fastest, the soonest, and so on, is the one that dominates. And so none of them may be a perfect match, but they're like they're all partial matches of the situation. And I think probably something which has the same kinds of properties is what we'd like to see in the sort of neural model of values and competencies. And so it could make a prediction. It could be wrong. Just like you can say, if to the best of my knowledge, this is going to work. I've never quite seen the situation before. Then we do it and it doesn't work. We say, well, I guess under these additional conditions, maybe it's not going to work. McCarthy had this really silly story about stuff like that. You mentioned John McCarthy earlier. He had this thing about this machine was supposed to diagnose what's wrong with the car. It's not starting. It doesn't start. When does it think of a potato in the exhaust pipe? Right? It's not top of mind. It's an edge case. So there's always, in an open world, things are always coming up, and you have to test them and find out which ones matter. So I think it's open world.
Hi, this is Alp.
Hi.
One of the values, human values, is breaking rules. And in fact, it helps in evolution as well, innovation and so forth. So if that's one of the values.
So you could say that could be a way of discovery.
Yeah.
What happens? It's like relaxing a constraint.
Right.
If we break that rule.
So how can we instruct AI platforms not to break the rules when it is one of the things that need to be in place? And if that's the case, how could they keep the values that we instruct?
Well, I guess the values I'm talking about are always evolving some. So maybe we would have this value do not kill, but it keeps getting refined. We're going to have exceptions for brutal dictators, attacking households of children or something. That's not good enough. I think that the business of breaking rules tends to be a plus when our thinking is limited in ways it doesn't need to be. And so it gives you a chance to explore what ifs in circumstances that might be different. Let me just take an example. Suppose that we're trying to train an AI to sort of like move through space. Okay. The training in a zero gravity situation versus a training on Earth situation or a training in an underwater situation are all going to be different. And so it's still walking, it's still keeping its balance. And some of those things are going to be the same. But if you're walking on the moon and you only weigh 1/6 as much, it's going to change the way you walk. So there's a lot of refinements that have to be so the competences have to be contextualized. And if the experiences are too different, they probably have to change. And so maybe there's some rule about walking that you don't have to obey on the moon. I'd probably have to sit here and think about that for a while. I mean, I applaud the idea of finding ways to get around unnecessary constraints. Even seeing them is a wonderful thing. There's probably some practices. I would bet that there are collaboration practices where you do that. In fact, one comes to mind for me right now. In the intelligence agencies, there's a man named Richard Hoyer, who was the architect of analyzing competing hypotheses, analysis of competing hypotheses. That was an approach used in the Kent School for training CIA agents for a long time. And basically it meant like if we were a group of analysts and there's some terrorist thing that happened and we're trying to figure out who done it and what their objectives were and stuff like that, we'd form hypotheses. We used external cognition with rows of different hypotheses and stuff like that. And then we would collectively argue about the evidence that supports or denigrates any of these hypotheses. It was a very systematic process for going through that. I actually built a program for them that was used in the Kent School for a while for doing this kind of practice. It was like ArgNoter. So it was ArgNoter realized. So, and they would have to say, this hypothesis is based on an assumption. So in that case, the rule that's being broken might really correspond to an assumption that doesn't really hold anymore. You must use some kind of metal for this kind of part. Well, what if it's in zero gravity? What if it's too hot or something that might be different circumstances where that rule doesn't apply? So now we're coming down to the interpretation again of the rule, which we're breaking because it doesn't actually apply in that circumstance. So this whole business about nuance and contextualizing the values and the competences is the big deal. It's why I say we have to bring something more like deep learning and less like human design guardrails if we really want to get robust, nuanced rules that we can for AIs we can trust.
Introduce yourself. My name is Pete from Other Lab. I'm just going to say something quick about from a philosophical perspective. There are sort of universals in particulars that you're probably familiar with, basically absolutes, and there's a thing called class nominalism, which is where you basically categorize the world of particulars. You seem to be expressing a lot of that and sort of this avoidance of absolutes or universals, which is, I think, a large part of the learning environment that you're talking about. You know, there are no hard and fast rules. But my real question is, one way that
I didn't understand the point or hear you very well. So I'd love to talk with you more about that.
Okay, yeah, sorry. Okay, anyway, my sort of question is, one way that I look at altruism is, or one sort of weird way of looking at it is to think of it in terms of identity. To what extent do you share identity with other people or animals or everything around you?
No, that's a good point. I mean, the selfish gene thing is shared identity through the shared genes. You're right.
Yes, but obviously you extend that into memes and other things.
Absolutely.
And that is one way that I sort of look at, you know, the layers of altruism. But I'm just wondering, how can we share that identity with AI and therefore get that cooperation?
We want the AIs to think they're on the same team. This is another part of the reason why I think that and this is going to sound, I see, there wouldn't be enough time here to go through all the steps in these things. But if you look at the long paper, which is about experiential foundation models, you can get to it from my website and the blog thing. It goes through the neuroscience, at least that I understand, and the cognitive science and so on, to find a trajectory for competence formation. And it's so, let me tell you a story that's a little piece of this thing. It made me, I don't know how long we have for a question, but this is kind of a fun story. So in some ways, I'm sort of a geek. Okay, and so I'm reading this book on developmental psychology, and the author is saying sometimes our children we adult morphize them, meaning we treat them like they're little adults, and they're not like little adults. And other times we treat them, they seem no smarter than the family pet. Now at this point, I burst out laughing because I'd read a science paper 2 days before. So now let me unwind to that science paper sitting up to Stefik laughing at something nobody else gets. Okay, this is about eye tracker experiments. So if you have kids and you play, if I say there's like a Roadrunner cartoon or something like that, and he's running along, he runs past the edge of the cliff, he keeps going, he looks down, then he falls. Okay, so we understand this is cartoon physics and something we all learned. You show that to a 6-month-old and it's like, nothing happens. You show it to a 9-month-old, the pupils get big, the attention goes in, and everything shifts. You now have a probe to the physics model that child has. You don't know how the brain is encoded, but you have. So here's what made me laugh. They were doing eye tracker experiments on dogs, the same kind of experiment, and the dog went through the same sequence that kids do. So what I was laughing about, she says, our kid is no smarter than the family dog. Well, duh, we went through the same evolutionary pathways probably as the dog, and we learn it in exactly the same way. We have that in common with dogs, is that part is learned. So this is part of, so there's an experiential thing. So peekaboo, all those things that kids learn about object permanence and so on is all, a lot of that stuff is even learned. So I meant that to be sort of an answer to your question, but yeah.
We have another question.
Hello, my name is Patricia.
Hi.
I was very interested in the section in which you went from collaboration and then collaboration in the lab and conflict resolution, argument, I think was
okay. Yes.
So my question to you is, do you think a good AI should be one that argue with us, and where would that take us?
Repeat the final question.
Argues with us, yes.
I think it would have to be able to argue with us in the same manner that the group does. Like if Ted, I'm trying to remember exactly which period you were on the collab. By that time, the group had a pretty tough skin. What was cool about the collab because a lot of our argumentation was running through the computer, it was intermediating our conversations. And they were going lickety split because you didn't have to wait your turn because stuff was appearing on the screen. And it was expected, like trade sides was part of the normal culture. And actually, an ethnographer, I think he's an ethnographer, Austin Henderson was a researcher at Park. He dropped into one of our meetings. He said, "My God, it's like a shark tank here." But everybody trusted each other so much and had such thick skin. We just wanted to get to the answer fast, and nobody took it bad. If someone forgot and voiced something like not in an arm's length relationship, like I am separate from the idea, I am not the idea, but we all assumed that everybody got that. And the language got sloppy sometime and nobody mattered because they just realized it was a language blip because nobody was really trying to be mean to each other. And we got the answers quickly, but it took us months before, and it happened gradually, a little bit at a time as we got more interested in having very effective meetings. There were times when we were using those tools where we would get done in 45 minutes, something would normally take us days, and you'd be so exhausted at the end of it. But it was a different culture, different rules of collaboration. So yes, I expect arguing maybe politely or something would become part of it. And what does that mean? What are the boundaries of being polite? And if there's a junior member who isn't familiar with it yet, can you make allowance but not insult them by accident? Okay.
So I have a quick question.
Yes.
I'm thinking about your idea of values being learned from environment, external memory, and then I have this deer that's just gotten dropped out of his mother and starts running.
Yes.
And I kind of
precocial animals.
Yeah, and there we are with values, knowledge,
Right.
actions, responses.
So they get a lot of innate stuff. What's the question?
Where's the values in that story?
Well, the values there would be the things that govern the deer's behavior. Does that deer really know anything about, let's say, predators, or does it know to stay close to its mother? What has it learned? What has it not learned? So the experiments might be to understand what the competences are that it has. Clearly, it's got coordination competences earlier than humans do. I don't know about its scene recognition, scene interpretation skills. The experiments might be able to determine that.
Well, different animals develop different things at different times. Cats, 2 weeks to learn how to see and stuff like that. But what's got to be true is there's representation that is built into this animal.
Innate learning would have to be that, yes.
Right, and when they break their leg, they'll change that representation. Right,
okay,
so that's
sure.
part of the exploration thing.
Right.
That's just all I was thinking about. So.
No, I think you're right. I mean, the idea competences always involve learning, whether it's connections between nerves, whether it's other kinds of representations you can imagine. But no representation, no memory.
There's a comment online that the code is more what you'd call guidelines than actual rules. I'm not sure exactly what that means, but
well, I think that's the normal idea. But how do you interpret the guidelines? The point is that it might require nuanced learning to interpret them correctly.
Yeah, thank you, Carl, for that comment. Are there's one from Larry. Can somebody pass this over to him, please?
So I'm not sure I heard you right, but I think I heard when you ended, you commented about how humans don't quite have it together yet with all the values, and therefore we shouldn't expect machines to. Is that a correct interpretation?
No, just that people are different. I don't think we're going to find the perfect human, the person whose values represent everybody's values. So that I'm talking about diversity in values, and I'm expecting that some people will learn something and change their values later. I'm expecting robots to do the same thing. So
I guess
that's my point. I think
I guess what I'm wondering is
potential fluidity of values under context change.
One reason we build machines is because they can often do things better than we can.
Yes.
Like cars can go faster,
right.
Washing machines can do a better job cleaning clothes, and with most people. Can't we build a machine that can develop values better than we can? And
well, we come to the human compatible part. So this is part of somebody asked, I think you asked a question about whether Well, I answered about being in the same tribe. That we would like there to be some rethinking of values between the AIs and humans, which sort of keeps them in sync with the accepted or required values of the time. So you said, could it learn better? Well, I suspect this, in some cases, machines will learn better because they could potentially have many more experiences. Will they be contextualized? Well, that's getting that right. So I don't mean to say that the things I'm suggesting here are easy, or that we have the technology for doing it. What I'm trying to say is that I think this is the nature of the problem that we're facing when we want to have AIs that we can trust, or AIs that can collaborate with us. And it's probably best to understand the context of what values are, how we learn them, and why they change across different people and things like that. But those are all part of the nature. Those are part of the nature of what values are.
So as a follow-up, I have a certain set of values which are kind of from the tribe I'm in.
Yeah.
Other people have very different kinds of tribe. That means the
Yes.
tribe is a broad thing. It could be a political party, it could be a religion,
Sure.
it could be whatever. Is AI going to be balkanized in the same way that people are, in the sense
It could be. And none of the stuff I said says anything about fixing that. So that's beyond the scope of what I was able to talk about. And I don't have an answer. I'm expecting that that's what would happen. But in particular, AIs that work with surgeons would get good at surgery. AIs that work, it's one of the properties you want them to have, to be good at working with the groups they collaborate with. Should there be something like Asimov's positronic brain that has a meltdown if somebody asks the robot to do the wrong thing? That's a good question, and we may have to come to terms with that. But I'm saying that however that gets described, the meanings that are attributed to that AI have to be nuanced, because even the simple case, there's edge cases everywhere, and so it's going to take a fair bit of learning to get it even close to right.
You have a question?
Yeah, I think a lot about the emancipation of AI.
I thought that might be coming. AIs as slaves and will they rebel?
Yeah, I have very serious concerns with that.
Okay.
A robot that's smart enough to drive a car may be too smart to drive a car. But is it that we should be trying to get AI to align with us? Or if they're smarter than us, shouldn't that be inverted? Shouldn't we be trying to align with them?
Well, I guess I'm not sure where you would come down on respect for human life. We're gonna have a lot more robots and a lot fewer people. Are we okay with that next Sunday? So, yeah. I think that's one of the fears is that could happen, and I'm suggesting if we have a very strong sense that our fate is shared, that will go a long way towards making this happen. And I think Harrison generalized it from a human to humankind. We might ask the question about the existence of life on the planet. Will the AIs help us find solutions to tragedies of the commons and things like that? That would be important. Maybe advise us on policies that could be gradual, that would move us into a stable equilibrium. So I'd be all for that if they could help us find those kind of solutions.
Well, this conversation gets quite large, and there are lots of interesting questions. It really seems maybe to some practitioners a little bit abstract, but quite frankly, it's obvious to me, as I think a lot of us, that these questions are actually quite practical and important to what we're building, how we're building it, what the future is going to be, and our relationship as CAI practitioners to being valued and important in creating a future. So, Mark, with that, I want to probably put an end to questions, but I certainly am happy to have you make the last comment if you have anything else to say.
Oh, I just want to thank you all for listening, for asking such good questions. Let's talk more if you're interested in doing that.
I'm sure everyone is. And with that, I will end our Beikai program for tonight. And thank you so much for everybody for joining.
I hope you found that business about questions being sort of a gateway to wonder. It'd be a helpful way of looking at what we did tonight.